We're going to look at linear substitution. So we have two equations, and we also have two exponents in each of the equations, which is perfect. We need two equations to solve, for two unknowns. Our unknowns are the x variable and the y variable. Now, what we got to do to decide first when doing substitution is what we want to set one of the equations equal to. The concept here is to get an equation equal to one of the variables. Let's say y is equal to happy face. Okay? Once we have that value, we replace the y in the other equation with, try to draw a happy face there, with happy face. Now obviously it won't be happy face. It'll be some numbers and some symbols, but that's the idea behind it. So I can look at these two equations, and I'm going to tell you it's going to be far harder to work with equation 1 if we try setting this one equal to a variable than it is to work with this one. This one, there's no real coefficients. Technically a 1 is there. It's really simple to do. I'm going to isolate for x in this equation. All right? So we're going to focus on equation 2. And sometimes it takes a little bit of time or practice with it to recognize which will be easier with. If you're unsure, it doesn't really matter. Just go ahead and start doing it. So I'm going to take equation 2, which is x plus y is equal to 75. And like I said, I want to isolate for x, which means I'm going to move y. Y is going to go to the other side of the equation. So when we do that, we have x is equal to 75 subtract y. And lo and behold, x is by itself. X is equal to 75 minus y. So now that we have this amount here, we can replace the x in equation 1 with that. So let's get equation 1 out. Equation 1 was 82x plus 95y is equal to 6,241. So like I said, what we're going to do here is we're going to replace x with what x is equal to from the other equation. So we're still in equation 1. The only difference this time is I'm going to go 82, and in brackets I'm going to put 75 minus y. So I've replaced our x value with what x was equal to in the other equation. Everything else stays the exact same, plus 95y is equal to 6,241. Great. Now we can use distributive property. And if you take a look, if you look at this equation, there's only one variable left. It's just the y. So we can isolate for y, and we can find y now. So like I said, we're going to use distributive property here. 82 times blah and 82 times y. Now, I definitely cannot do 82 times 75 in my head. 82 times 75. 6,150. 6,150. It's a great song there. Minus 82y plus 95y is equal to 6,241. Now we're going to collect like terms, okay? Again, remember I said that our y's, we have two terms that incorporate the y variable, and we have two constants. So what I'm going to do is I'm going to put the variables all on one side and the constants on the other. So very quickly, I'm going to move this rather large constant here to the other side. So it's going to be subtract 6,150. So when we do that now, we'll have negative 82y plus 95y on the left side of the equal sign. And on the right side, we have 6,241 subtract 6,150. Okay. Here we just subtract the coefficients. This is essentially 95 minus 82, which is going to be 13. I think so. Double check. For some reason, I'm rather unconfident in that, but I'm pretty sure it's 95 minus 82. 13, okay, good. I haven't lost it yet. 13, and it's positive 13y. Okay. Here we're going to get 91, I want to say. 6, 2, 4, 1, subtract 6, 1, 5, 0. Yeah, all right. Great. This is far simpler to work with now. Still, the goal is to isolate for y. So we're going to divide both sides by 13. And 13, it'll be 7. Y is equal to 7. Great. So we have one of the variables. Y equals 7. Let's zoom out again at all this work we've done. Y is 7. Now, I need to take y is equal to 7 and plug it into either equation 1 or equation 2. It doesn't make a difference. Again, from looking at the two equations, it's going to be far simpler to plug into equation 2 and solve for x than it is going to be into equation 1. Okay? So I'm going to take equation 2 now. Equation 2, which was our x plus y equals 75. So equation 2 was x plus y is equal to 75. We're going to replace y with the number 7. So x plus, we'll just color blue for purple here, 7 equals, I think it's 75 actually. Yes, it is. Okay. Sorry, I wrote that number incorrectly. 75. Well, to isolate for x, we move 7 to the other side, so we're going to be subtracting by 7. So x is equal to 68. Pretty sure it's 68. And there you go. You have your two answers. Y is 7, x is 68. And if we check it out here, x is 68 and y is 7. Here are two linear equations. That's where they intersect each other. So we got it.